Welcome. This is Chapter 1, Section 1, What is Chemistry? And when we finish with this, I would like you to look around the room you're in and identify 10 to 30 different objects and make a table with 3 or 4 columns and list these items in each column by something that makes each one of the objects similar. So think about what characteristics does each item in a group or column have in common, and then within a group or column put them in some kind of order from top to bottom, such as small to large or one color to another color, and then sort of identify what characteristic you used. Okay, what we're going to do in this section is we're going to describe how chemistry is part of your daily life. Everything around you is related to chemistry. We're going to talk about the 3 common states of matter and a 4th state of matter which you're probably aware of, which is plasma. We're going to talk about the difference between physical and chemical changes, give you examples of each, and hopefully when we finish you'll be able to describe what a physical change is and what a chemical change is and how they're different. And we're also going to look at chemical equations. We're going to identify where the reactants are in these equations and where the products are. And we're going to list 4 observations that help you identify whether or not a chemical change has taken place. Okay, so let's get started. First of all, a chemical is any substance that has a definite composition, such as H2O, S8, C2H2. They have exact relationships. A chemical reaction is the process by which one or more of these chemical substances changes to produce one or more new substances. The states of matter are the physical forms of matter, which are solid, like your table, liquids, like the water that you drink, gas, like the air around us, and plasma, which is in the sun and in the stars, where something gets so hot that the electrons are driven off and it's ionized. Okay, now, if you look at these, how does temperature affect these physical forms? Generally, if we look at water, at low temperatures, water is a solid. But as we heat it up, it liquefies, just like metal, if you heat it up hot enough, will melt. And if you continue heating it, like on a stove, the water will evaporate and it will become a gas. And then if you get really hot, such as in lightning or in the sun, the elements turn into plasma. Okay, what's the difference between a solid, liquid, and a gas? Okay, solids have fixed volumes. Think of it as a cube. You could put it in a glass and it would not would not take the shape of the glass. And the shape that results from the way the particles are arranged pretty much stay the same because the particles don't move past each other. As you heat up something like water, liquids have a fixed volume, but they will move to take the shape of the container that they're in, at least at the bottom if gravity is pulling down on them. They don't necessarily fill the top. But if we have a closed bottle and you put a gas in it, or if there's a gas above a liquid like in a soda bottle, it doesn't have a fixed volume, it doesn't have a fixed shape, because it will expand to whatever volume we put it in, and it will expand to take the shape of the container. Okay, in your workbook, it asks you to draw 3 different states of matter. When you're drawing a solid state, all of the molecules are arranged, they can't move past each other, and they take on a very orderly form. If you have a liquid, notice that the different molecules are facing different directions. They completely fill the container that they're in from looking down on it, but may not fill up the top of the container. On the other hand, if we have a gas, they completely occupy the shape of the container they're in. If the container doesn't have a top on it, they will continue to expand and go into the room. Now, physical changes are things like when you paint a wall or you cut something in half. Changes of state are also physical changes. So if I melt an ice cube, that's a physical change because the identity of the substance doesn't change. On the other hand, a chemical change occurs when different elements or molecules combine to form new substances. Okay, if I have mercury 2 oxide, it's a powder, and if I heat it up, we get a silver liquid in the bottom of whatever the container is, say perhaps a test tube, and the oxygen actually turns into a gas and escapes. As we look at this equation, the mercury oxide on the left-hand side is a reactant, and they are used up in a reaction. The products are the items that are on the right side of the equation. In this case, it would be the liquid mercury and the oxygen gas. They're what's made up in a reaction. If you think of cooking, these are our ingredients, and these are end products. If this is a cake, this is going to be the flour, the water, the eggs, etc. And this is going to be our cake. So, how do we know if a chemical change has taken place? One way we can know is if it gives off a gas. If we put acetic acid or vinegar into sodium hydrogen carbonate, which you know as baking soda, there are bubbles given off. And that tells us that a chemical reaction has taken place and we're actually giving off a gas and forming some kind of another compound. If we take two clear liquids, like sodium sulfide here and calcium sulfide here, cadmium nitrate here, and we pour them together, a reaction takes place where the sulfide from the sodium sulfide and the cadmium from the cadmium nitrate break apart and join back together to form a yellow precipitate of calcium sulfide. Another fun reaction is if we take just pure aluminum and we take iron 3 oxide, which is rust, and we mix them together and are able to ignite them, they will burn and release lots and lots of energy in the forms of heat and light, and they will actually melt the iron, and you'll get a piece of iron down in here. And then a last one is if I have phenolphthalein in a acid solution and I add a base to it, it will turn pink, telling us that a reaction has occurred. So when ammonia is dissolved in water, a color change will form, it will go from colorless to a pink color. Okay, so what are the 4 different ways we can tell that a chemical reaction may have taken place? If a gas is given off, if we form a precipitate, if we release or absorb energy, if there's a change in temperature, such as an ice pack where you break something and there are chemicals in there and the chemicals cool off, or if they give off light and energy and then a color change in the reaction system. So, thank you for listening. That is Section 1 of Chapter 1 of Holt Chemistry.